I'm Kirk Harnack. On This Week in Radio Tech, I'm joined by Chris Tobin and Tom Ray. When is giving 110% not such a good idea? When it's modulation. Twert is up next.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Radio Tech is brought to you by Cachefly at CACHEFLY.com.
This is This Week in Radio Tech, episode 99, recorded September 14th, 2011, when 110% is too much. This Week in Radio Tech is brought to you by Telos Systems and the new VX Voice over IP Multi-Studio Talk Show System. On the web at telos-systems.com/VX. It's time for This Week in Radio Tech. Hello there, I'm Kirk Harnack. I'm your host for this crazy show. We talk about stuff in radio technology, which usually includes audio and sometimes, I guess about half the time, RF technology as well. We're talking with engineers who help get audio, through the transmitter, through the audio consoles, and out to whatever listening device you have. Radio's been around a long, long time, and sometimes it seems like an old-fashioned kind of sleepy technology. But hey, even compared to all the IP and the bits that whirl around through 3G and 4G connections and Wi-Fi and wired connections, radio still has a place. It's still the most popular way that folks get news, especially when they get instant weather reports. And it's still the way that most folks are still entertained. Even though a lot of folks who watch this show and watch other shows or listen to other shows on the Twit network, a lot of us, hey, we don't listen to radio much anymore. We also don't watch TV much anymore. But that's what we're here to talk about, how to get these signals out to all the folks who do listen to radio and watch TV. And along with me, to help me out with the show, got a couple of great engineers. First of all, the great engineer who occupies the Hudson Valley of New York. He's the engineer for WOR and Buckley Broadcasting. It's Tom Ray. Hello, Tom.
Who's rocking and rolling, bopping and strolling, pumping the wattage into your cottage. Good evening, Kirk.
we need to give you an air shift, Tom.
Hey, we should. You won't have a license when I'm done, but, damn, you'll have ratings.
So, Tom, tell us what you do during the day.
Sleep. No, I'm a VP of Engineering for Buckley Broadcasting, WOR. I'm in charge of WOR and all the Buckley stations.
Good deal. All righty. And also with us, another great engineer. Recently, he's been with the CBS stations for quite a few years in New York City, but now he's doing something a little bit different, still involved in technology and the broadcast business. It's Chris Tobin, the best-dressed engineer in radio from Manhattan.
Hello, Kirk, Tom, and our listening and viewing audience. Yes, up until recently, I was working with the CBS radio folks here in New York City, and this month I've started a new gig as president of Musicam USA. So, like Kirk, I now have codecs in my closet and underneath the bed and all over the kitchen, and trying to make sure the technology gets out there in the world of IP. So,
well, hey, when you get settled into that new job, I hope you're going to update us on what you guys at Musicam are doing in terms of IP codecs. I believe you guys do audio, and you got some video products as well there.
Yes, we have audio and video, and I will have some information actually probably ready by our next broadcast. Yes, definitely. I can get some stuff together.
Well, our show is brought to you this week by Telos Systems. Telos happens to be my employer, and I thank them very much for that, and I thank them also for sponsoring This Week in Radio Tech. I'll tell you more about Telos Systems a bit later in the show. Also, I want to thank Burke for switching the show today, so watch for all the terrific things he does and how quickly he just jumps right onto the graphical elements and sticking things up, and he's always got whoever's talking, it's their picture that's on the air. Thank you, Burke. I appreciate that. We have a show that we're going to talk about modulation, and not only in terms of, we're going to cover it a little bit from a technical point of view. Okay, I think most of us get that, and we've also done some previous episodes about amplitude modulation and frequency modulation. Yes, the analog types of modulation, as opposed to all the digital modes that are out there now. But we're going to cover this also from a practical point of view, and maybe an office political point of view, an interstation point of view, an intra-station point of view. What are some of the pitfalls and pratfalls, and how do you just get around this thing of modulation? So often hey, I've walked into the program director's office, or he's walked into mine and said, can we turn up our modulation a little bit? We need to be a little bit louder. And I'll start things out by saying, hey, with FM, certainly with FM radio, turning up the modulation is probably the fastest way to obtain loudness. Faster than I mean, once you're processing the audio to some degree, and you have kind of an average going on there, modulation. For every 1 dB more modulation, you get about 1 dB more volume, right? So let's cover a couple things first. We're going to be talking about amplitude modulation and frequency modulation. The kind of good thing about amplitude modulation is it's a set physical limit. It's a physical phenomenon. There's nothing arbitrary about 100% amplitude modulation. With amplitude, we talk about negative modulation and positive modulation. With amplitude, AM radio, there's this carrier wave, and it's there all the time. Let's say, Tom, your station, what's the frequency there? Is it 710?
710, that's us.
710 WOR. And so if you guys have dead air, there's no audio on, what's coming out of the transmitter at that instant?
52,650 watts of carrier, and that's it.
What?
At 710.
What? 52,000 plus watts of unmodulated carrier.
That's right. It's a great way to warm up the fish in the swamp.
Oh yeah.
See, we even look. I guess mentally. I mean, logically, I should know that, but you put it that way, and it's 50. And you're putting out a little bit more than 50,000 watts to make up for losses in the directional system, right?
That's correct. With a 50,000 watt station, you are allowed plus 5% over nominal, 50 kilowatts being nominal, to make up for any losses in the phasing and coupling networks. So, and let me guess, you use every bit of that 5% extra, don't you? Oh, you bet.
Yeah. So you got this carrier coming out of the transmitter, and if there's dead air, this carrier is neither getting stronger nor weaker. It is 52,000 and change watts of RF power at 710 kilohertz, and lots of money per minute to the power company. Yeah, absolutely. Now, pushing aside, notwithstanding the fact that you're transmitting HD radio on AM, you're still transmitting HD radio, right?
Oh yes.
Okay, so let's forget about those carriers for the moment. Just consider the AM part of this. Help me understand the difference, or what happens with negative modulation and positive modulation with AM.
Well, with the negative modulation, what you're doing, if you were to take a look at the wave coming out of the transmitter, that would be carrier. It's not doing much of anything. It's just kind of sitting there, and if you expanded it, if this were an oscilloscope, it's an imaginary oscilloscope, you would expand this over here, and you would actually see the sine wave of 710 kilohertz. But we're going to talk about it in audio terms, so what we're going to do is we're going to compress this in here so it looks kind of like just a bunch of squiggles. And the top and the bottom, this is the center line here. The carrier is not doing anything at zero modulation. When you modulate, you're going to put a audio wave onto this carrier, and you're going to have a negative trough, and you're going to have a positive trough. This is going to come in, and right when it touches and you have zero carrier left, that is minus 100% modulation. If you increase the audio twice the resting, so in other words, from here to here, twice that is 100% positive modulation. And as you can tell, if you go this way and you hit zero, there's nothing past zero except splatter.
So the 100% negative modulation with AM is you can't go beyond that. There's no such thing as 101% negative modulation with AM, right?
No, once you hit minus 100%, the carrier gets clipped off, and when that happens, nasty things happen. That's when you splatter, and you have all kinds of nasty harmonics start showing up that tick off your neighbors.
Well, and I think most engineers who are gifted, who are aware of the current art, will maybe clever in the art. Most engineers would say that don't even go near 100% negative modulation with AM. You know, limit yourself to 96, 98, 94%, some number, so that the carrier wave never actually clips completely off. Because that just causes, well, it causes a number of problems, including some radios will interpret that as more distortion. They'll get real distorted when that happens. Now, so this
that's
is
correct.
Yeah.
And that's why we limit it. So.
Yeah. So now on the other side, though, positive modulation, you told us what 100% is. It's basically, you know, doubling the size of that wave. I guess is that doubling of the voltage, the instantaneous voltage there?
It's the doubling of the instantaneous voltage, and so if you do the math, if you double the voltage, you quadruple the power. So a nominal 50 kilowatt carrier at 100% positive modulation is a 200 kilowatt peak. So,
and there's power being added to this. This whole other discussion. There's power in the sideband, so your average power goes up. Well, let's see. If you spend as much time at at or near 0 as you do at or near ×4, well, obviously the average is going to go up because your average was some number. Let's say 1, and then part of your time is towards 0, and part of the time is ×2. Well, anyway, the power ends up being averaging higher. But what I wanted to get at is with AM, we're actually we're not constrained by 100% positive modulation the way we are 100% negative modulation. It's physically possible to do more than 100% in the positive direction while limiting ourselves to 95, 98, or 100% in the negative direction. And you call this, more positive modulation. You can actually go over 100% positive modulation. And in a previous episode, we discussed how you achieve that. You can achieve it through the audio processor by having the audio processor limit the negative going audio that feeds into the transmitter, limit it to some amount that equals about 95%, but not limit the positive going audio until you get upwards of a higher number, like 125% modulation. Tom, tell us what that positive modulation does for you with AM.
Well, that additional positive modulation, and we're allowed up to plus 125% legally. Notice I said legally. That will give you a little extra loudness. And also by not constraining that positive peak, you can back off the limiting just a little bit. It'll give it a little more of a natural sound because, let's face it, talking right here, talking face to face, you're not limited. You have a certain dynamic range. Sometimes you get louder, sometimes you get softer, but it gives you that extra. It gives you a little extra oomph. And my understanding is the reason you're allowed to go to plus 125 was many years ago. People were kind of doing it anyway, and the commission finally said, okay, well, we know it doesn't cause any trouble going beyond 100% modulation positive, so let's come up with a limit and let's make it plus 125. And that's actually kind of a practical limit because, once again, as with the negative modulation causing distortion in the detector, if you go too high, you're going to cause distortion in the detector too. So you want to be a little bit careful on that.
All right. So with AM, what we're establishing here is that AM has this physical limit of 100% negative. You can't go beyond that. You can do something more than that positive, but you're introducing asymmetry, which done some ways can actually sound natural enough or actually be more natural. And on the other hand, you can also create this asymmetry, this more positive than negative. You can create that artificially. And some audio processors have done that by just injecting some DC and shifting the whole thing up or down. All right. That's amplitude modulation. Frequency modulation is quite a bit different in terms of what do we call 100% modulation, and what happens when we approach that, what happens when we go over that. And I'm gonna turn the discussion over here with Chris Tobin for the FM portion of this all the time. I know you do FM as well. Chris, my understanding is with FM, we have this arbitrary, in broadcast FM in the U.S., we have this arbitrary limit of a 75 kilohertz of deviation from the carrier frequency, right? So let's say if a station is 98.10000, if you're 98.1 on the dial, you can deviate the carrier. Of course, that's what FM is. We're moving the carrier up and down in frequency in correlation with the audio that's being fed into the modulator. So we can go up to, what, 98.1075?
Yeah, that's about right.
Is that about right? Yeah. And then down the 90.025 on the dial. So the carrier actually swings between these 2 points on the dial, and we call that 100% modulation. Have I got that about right?
Yeah. 75 kilohertz deviation is considered 100% modulation. To visualize it, you take the sine wave that Tom was talking about earlier, rather than the up and down of the sine wave changing in size. The sine wave moves from left to right along a line. So if you have a straight line on a piece of paper, put a sine wave on it, and the louder you get with modulation, or the more modulation you inject, the waveform goes from left to right farther and creates side bands and goes all the way out. Does not go up and down in height, so to speak. And
right
75 kilohertz is the max. 75 is 150. All the stations are separated by 200 kilohertz of, what do you call it? Guard band. And that's how they work out the channel assignments.
All right.
Pretty
so,
straightforward in that respect.
In both cases, there's some questions in the chat room about this. With amplitude modulation, the frequency of the carrier remains the same, and it's the strength of the carrier wave that goes up and down in perfect synchronization with the audio. In fact, it's controlled by the audio signal. So with AM, the carrier gets stronger and weaker at the rate of the audio signal. With FM, the carrier stays the same strength all the time. At least it's supposed to. If you don't, then you have AM synchronous noise. And the carrier stays the same strength, and it moves up and down in frequency in perfect synchronization with the audio that's modulating it. There's a bit more complication than that due to a few other factors, but that's essentially it. So what we call 100% modulation with FM is purely arbitrary. In other words, we could have called 80 kilohertz deviation 100%. We could have called 50 kilohertz deviation 100%. We could have called 25 kilohertz deviation 100%. If you have a two-way FM radio, it's quite likely that 5 kilohertz of deviation is 100%. With that kind of service. So there's various reasons for quality and overcoming noise, and that the FCC chose 75 kilohertz of deviation as being the standard, which is pretty much around the world the standard for FM modulation, FM deviation. All right, so we call that 100%, and what's interesting is there's a number of there's some ways to measure that, and I want to talk focus mostly on FM frequency modulation, because that's where it's so easy to break the speed limit. In practical terms, if you're an engineer at a radio station and you crank the modulation up a little bit, if you crank the modulation up to 105%, 110%, 120%, it doesn't really break anything. There aren't radios out there that just fall over and die. Nobody's radio at home catches on fire and smokes. Some radios may start to get a little bit distorted when you get over 100% modulation, because the radio is designed to have the best performance at the proper legal modulation in the design of the IF skirts and the filtering and all that kind of stuff. But you can speed a little bit, just like you can in a lot of places in the U.S. you can drive down the interstate at 9 miles above the speed limit, right? 9 miles per hour above the speed limit, and you're not going to get pulled over. So let's talk about this overmodulation thing. Chris, have you been asked to overmodulate at any station you've ever worked at?
Well, hang on a second. Let me check and see here. Oh, okay. Sorry, I'm just checking my modulation right now. Oh, yes. Oh, yeah. Geez, I don't think there's any broadcast engineer in the industry that hasn't at some point in their career received a request to be competitively louder or beat the competition at their own game. And, there's different ways to do it.
Yeah, so what we're going to get around to asking here is, I asked that because I figured the answer was yes, and Tom, you've probably been asked too, hey, can't you just crank the modulation up a little bit and make us a bit louder on the FM station that you take?
Everybody's been asked. Everybody's been asked that question.
And I believe even public radio has had the same questions asked.
I've even heard of engineers. I've heard that there are engineers out there that just wanted to make the station louder on their own so they'd look good to their general manager or their program director, and the engineer would crank the modulation up over 100%. Yes, maybe I've done that before. So when we're doing that, when we're speeding, and a lot of times we justify it by saying, well, hey, our competitor's doing it too. Now there's this really opens up a whole big can of worms because, well, let's see, I'm not even sure where to go in this discussion because there's a lot of factors in perhaps knowing. Well, tell you what, let's stipulate that the main reason why a station engineer or programmer would say let's overmodulate, let's go beyond 100%, is because the competitor is. Competitor is louder. Maybe the competitor is using a better processor. Maybe it's better adjusted, but maybe the guy is just overmodulating. And certainly, I've been exposed to stations who were doing 135% modulation on FM. Now, you can't compete with that, even with the best audio processor made. That's several dB of free loudness. So what do? You turn you call the FCC and see if they'll come by, which they probably won't, and invite an inspection of your own station at the same time. What do you do? So you crank up your modulation and overmodulate just like they are. And then I want to ask this question: how do you accurately measure your own modulation? Not so hard to do, but how do you accurately measure the modulation of a competing radio station when you don't have access to their equipment? And I bring that up because I am a pretty firm believer that you cannot perfectly and accurately measure another FM station's modulation over the air, because you always have a certain degree of multipath involved. You'll always get a little bit of non-direct signal involved, and that will almost always cause the modulation on the other guy to read high. Now, I've done a lot of yapping here. Chris Tobin wants you to talk about a couple of these things: the competitive pressure you're under, and then actually determining what the other guy's modulation is.
Competitive pressure, absolutely. I mean, it dates back to the early days, I guess, when music first started out on FM, and the rating services and the analog radios, if you recall. Those in the audience that do and those who do not. There was a time when a radio dial was a knob that you turn from left to right, and a little vertical pointer would just move from left to right across the dial itself. No displays of numbers, you just guessed where you were. And those analog radios back in the day, the louder you were, the most likely you were to stay with that station. And that just, I think, over the years developed into a louder you are, the better off you will be, and the better numbers and ratings you'll receive, and your chances of survival are greater. And as time went on with the technologies, the digital radio tuners that came out and the push buttons, that thinking sort of really didn't play a part anymore. And, it's still used today. Measuring accurately, well, the FCC at one time, they used to use a Bessel null function technique where you calibrate a receiver using tones to generate the proper sidebands of 75 kilohertz and going out. And then that would be your markers on an oscilloscope, on a receiver, depending on the type of receiver. There was a certain brand, I can't think of the name, that the FCC used to use all the time. And that would be their method. They drive up to your transmitter site, get as close as they can to the transmitting antenna to minimize, as Kirk pointed out earlier, the elements of off-air reception, and get pretty close to where they want to see the modulation. Was it exactly 75 kilohertz or 100% or 99.95? Probably not. There was a certain little fudge factor because it's an analog display they're using, and I know over the years when I've sat with the FCC inspectors and they showed me what they did, it's close enough that you could say, yeah, you know what, you're definitely hot rodding or you're not. And, it's interesting. That's the one method that I've been told is the only one they would accept if you got into a screaming match with you and your competitor.
So let me make sure I understand, because I've heard this before, and you're confirming what I've heard, that when the FCC measures FM modulation, they do what they call a Bessel null calibration to mark 75 kilohertz of deviation as probably a line on an oscilloscope that they can set, and then they take the output of a receiver and feed it in the scope, and that's been calibrated to show them when they reach 75 kilohertz of deviation, the waveform hits this line. If it goes over the line, if there's any pips over the line, then that means they're over-deviating. Am I hearing you right?
That's the simplest way to put it, yes. There is a chart, a Bessel function chart, the sidebands and the number of sidebands and what you should get for a modulation index if you want to get really into the mathematics of it. But in general, that's what they do, and that's how it's always been done. Now,
so at stations... Practical. Yeah, at radio stations, we have always had mod monitors with, okay, there's an analog meter on them oftentimes, or nowadays there's a digital readout, but there's also a light that flashes when you hit 100% or whatever number you set the light to hit at. And we're gonna chat about the characteristics of when that light decides to light up too, because that can make a difference in your modulation. But you're saying the FCC doesn't use a method like that, where a detector, when it jumps over a threshold, will light a light up? That they have to actually watch it?
That's that controversial in the rules. I forget which rule number it is, where the number of peaks per second within a certain time window, and that's the time constant that's used by the modulation monitors, the peak indicator. There's a lot. If you really study the science involved in modulation, whether it be an FM broadcast or an FM land mobile radio, measuring it can be very difficult under certain conditions. What I used to do in the old days, I'd take the output of a tuner, the detector output, go to the inside, open up a tuner, a really good quality radio, take the detector output, put a BNC connector on it, isolate the circuit from the chip itself so you didn't load down the circuit and alter the frequency response of the baseband output, fed that into a scope, and I used that with a directional antenna, and you turn the antenna until the waveform became nice and clean and clear, so all the multipath was out. Then I'd use that, I'd go across the dial and mark it off on my scope with a little grease pencil where my modulation upper and lower was, and went across the dial to see where everybody else was. And 9 times out of 10, we were very, very close. And I never had to worry about somebody complaining that someone's louder than us because they're modulating 110 or 115, and I was only doing a measly 105. And it was very handy on many occasions when I worked with program directors who insisted we weren't loud enough, and I would demonstrate them with the scope and say, here you go. Here's what your tuner, this is what the tuner actually sees. It was receiving. And look at our waveform and look at the guys across the street. We're louder, their waveform is the same as us, and they're lower. So I said, we're on an even playing field. I even showed that to an FCC inspector once. He chuckled, and he's like, well, that's the closest you can get to a Bessel null. I said, yeah, that's what I thought.
So you've used this Bessel null function. I guess I've used this Bessel null function with a spectrum analyzer to find out when I was actually deviating 75 kilohertz. Can you describe how you do this? Seems like I had a CD that had some tones on it that were accurate, very accurate tones, because the Bessel null function depends on having some tones, and there were certain frequencies that you could play through your exciter, and you would turn the modulation up, and there was one particular tone that we used that it was the third null, and you'd turn the modulation up to 10%, 15%, 20%, 25%, and the carrier at some modulation level would just disappear. And all
That's
the
correct.
energy was all the energy was in these sidebands on FM. And then you'd crank up some more, and this carrier would return, and then at, I don't know, 67, 75, some number, it would disappear again. And you crank it up some more, and you get right to 100%, and the carrier would once again just whoop, disappear. And it was just a real tight, I mean, you go a half percentage of modulation either way, and you can see that carrier begin to come back in. But right where that was zero, that right there, that instant was, that's 75 kilohertz deviation. And so now that's where you set your peak light on your modulation meter. That's where you calibrate the peak light to come on.
Yeah, that's pretty much it in a nutshell.
I'm sorry, I asked you to explain it. I just remembered, oh yeah, I did do that a couple times.
Yeah, I mean, it's nowadays, I don't know, there's some monitors that I've been using that are very, very accurate and work very well with the proper signal in them. And if you'll make sure the multipath is minimal, and they can even measure that for you. You could get the output of the baseband, put on the scope, and look at it. You could do really well. And again, when it comes to loudness, Tom knows, with FMs especially, you can reach a point where it's subjective. I mean, I've had 6, 7 different tuners in my office, 6 different portable radios. Every one of them had a different loudness curve, if you will, to each of them. So I'd set them up on the bench and turn them on, and you play them one at a time. And subjectively, you have people listening with their back to the radio, and I'd ask them, okay, which one's louder? And I would just go across. And it was amazing. Their perceived loudness, not one of them was the same. So
really?
It's a tough one.
Why
some
do you
program
think that
directors
was?
get it, and others don't.
Yeah.
What's that?
Why do you think that was?
I'm not certain. I think a lot of it has to do with just design, costs. I mean, I got the GE Super Radio here with me, and this guy was this is very consistent. For those watching with video, I'll show it in the camera. It's a quite familiar sight for many. And this one is very consistent sound. Matter of fact, most of the portable Super Radio, the black ones, not that big silver one they had at one point, had a very consistent sound for the FM and even the AM. But a lot of other consumer radios, I notice a difference all the time. Matter of fact, you'd sweep it. I did put an exciter in the office and radiate a signal and generate my own frequencies and watch them come out of the tuner into a scope, and you could see they were not very flat. It was an interesting waves, Kirk coming out of those speakers. So you're playing a lot. A lot working against you.
Tom, at your FM stations that you take care of, how are you guys measuring your FM modulation?
We use a modulation monitor that we hook into the sample port off of the transmitter. As an example, in Connecticut, most of the FMs are on the same peak. So if you want to measure modulation remotely, you aim the antenna in the same place. And I usually use us as a reference, and then I can look at the other stations if I want to, and be reasonably assured that the path conditions are the same. So I don't, I don't really worry about the multipath issue when doing that. But we measure it at the sample port in the transmitter, and we're running. Let's see. Right now, we're running, not counting the HD radio signal in Hartford. We've got 67 kilohertz subcarrier and RDS subcarrier. We're injecting the RDS at about 4%. And the 67 is injected 10%. So we're running about 107% modulation, which is what we're allowed. And we're still pretty doggone loud.
In fact, we ought to explain this for some folks in the chat room. There's been a little bit of chat about this thing of when it's okay to overmodulate, and that is due to what we call RDS. RDS signals and other subcarriers that you can put on the air. Back in the day, we had subcarriers that were analog subcarriers reading for the blind, and maybe we still have those. Or Muzak services used to be distributed over subcarriers. Now there's different data services which are. And so these are extra little carriers added to the FM baseband. RDS is at what? Is it at 39 kilohertz? Did I have that right?
RDS is 57 kilohertz.
57, you're right,
yep.
Yes. 3 times the carrier, 57 kilohertz. And then you can have, I'm sorry?
It's the third harmonic of the pilot.
Yeah, there you go. And then you have 67 kilohertz as a possibility, and even 92 kilohertz as a possibility for extra carriers that can carry either data or kind of low-quality audio services there. So you put these on the air. Maybe it's a paid-for thing. The station's getting paid to put them on the air. Hey, years ago, back before they went out of business, Q paging was a nationwide paging service, very popular among over-the-road truckers, and several stations that I worked at had Q paging signals on them. So, what are you allowed to do, Tom? When can you overmodulate, and by how much?
The rule reads that with subcarriers, you are allowed 0.5% extra modulation for each percent of subcarrier injection. If you're running one subcarrier, your maximum is 105. If you're running more than one subcarrier, your maximum is 110%.
It was 110%, even if you had several subcarriers on, if you had some other technology going on. Right. But 110 would be the most, right?
Correct.
Okay, and the idea here was
all the carriers.
Yeah. And so that was to mitigate slight loss of loudness that you would have in your main carrier, where you're carrying your audio, because you had to back off your total modulation because of the subcarrier. So it mitigated that somewhat, right?
Right. And if you think of it, if all the stars align, because let's face it, your 67, your 92, your audio, not everything's going to line up. But if everything lined up properly for a modulation peak, if you're running a 92 kilohertz subcarrier at 10% and a 67 at 10%, and you have an RDS in there at about 3 or 4%, you also have 9% of stereo pilot. That doesn't leave a whole heck of a lot for audio modulation, because I mean, you've eaten up 34% of your modulation already in subcarriers. That's stuff people can't hear.
That's right. Hey, I was just reminded by a Navion in the chat room. I should have remembered this, because we've done this at numerous radio stations. You can use a subcarrier to bring telemetry back from the transmitter site. The various readings of what's going on there. If you have a one-direction STL, you can bring the data back over a subcarrier. Although I never liked, well, now that we have so much internet connectivity and it's easier to get phone service out of places with a box, like a cellular box, even if you can't get wired phone service, you can get cellular phone service. If the transmitter goes off the air, you have no more readings. So, the thing of bringing your signal, your telemetry back over the subcarriers, it's fraught with its own set of problems. Kind of like Q paging. When the transmitter's off the air, Q paging couldn't call you and tell you that your transmitter's off the air. There was a problem. Hey, we got to take a break at the moment here and talk about the sponsor of the show, which is Telos Systems. And when we come back, we got a couple of key things we're going to hit. One is we're gonna talk a little bit more, a little tech talk about modulation monitors and how they would react to these peaks of modulation and what was legal and what changed back in, I think, 1983 about the rules and how we've been working ever since then. Also, how to answer your program director about this overmodulation. Chris touched on that some. We're going to touch on it a bit more. And we are running a contest for the last couple of weeks and this week as well. If you retweeted the fact that This Week in Radio Tech was on the air, you're eligible to win an Omnia AXE software license. This is software that does audio processing in a PC Windows environment, does audio processing on audio, gets it exactly prepped just right to be encoded to a web stream for either MP3 or AAC encoding, and then it does the encoding too. So it's pretty cool software. We're going to have a winner for that before the show is over. And thanks to all the folks who retweeted the fact that the show is on the air. We're certainly trying to build our audience and make sure that every engineer knows about This Week in Radio Tech. All right, now let me tell you about my friends at Telos Systems. Hey, if we could get that webpage up here real quick. Just the overall page. Telos has been known for years and years as a company that makes telephone hybrids for putting phone callers on the air. And that was back in the mid-1980s when Steve Church developed the first DSP-based telephone hybrid for putting callers on the air. Steve Church, the founder of Telos, he was a talk show host, and he was an engineer. He was kind of frustrated with the fact that phone calls just didn't sound all that good on the air. Well, Steve put some brain power to that and put this new Texas Instrument DSP chip to work on that and developed the very first DSP-based telephone hybrid. In fact, I believe it was the first DSP-based product for a broadcast studio. It was the Telos 10. Well, then for years and years, engineers have been getting the Telos 1 telephone hybrid from Telos. It's been a staple of our company's business for many, many years. Well, guess what? It's no longer available. Not at all. The Telos 1, quite a venerable product, and Steve Church really put his heart and soul into that product some years ago, has been discontinued. But it's replaced by a better product. It's the HX1. The HX1 from Telos, and also the HX2, which is a dual hybrid. That is the new. That's the new product at the low end of the cost scale. These two hybrids, the HX1 and the HX2, they are just filled with features and incredible performance, better than the Telos 1. It's got automatic dynamic equalization to equalize your phone caller's audio. It's got a dip switch setting inside, so you can set up the phone interface, the phone line interface, to work properly with really any phone company in the world, and they are different around the world. You think a POTS line would be a POTS line anywhere. Well, unfortunately, it's not so. So you have the Telos HX1 and HX2. There's also the NX talk show systems from Telos. There's a 6-line system, the NX6, and a 12-line system, the NX12. And these just have superlative hybrids in them. Also, they handle multiple lines of either POTS or ISDN, or even a combination of both, half and half, if you like that. The NX12 is used by a lot of the major talk shows across the U.S. and even around the world. Plus, there's a lot of really cool third-party software to do call screening and let you set the calls up and let the talent know who's on the air. It lets the talent and the producers decide who to take next on the air. And then finally, I want to let you know about the new Telos VX phone system. And we'll have some videos about this later on, hopefully in the next couple of months, that explains the VX phone system. But basically, it's able to work off of voice over IP circuits or SIP trunks. And you can bring SIP trunks directly into your radio station and hook them into a Telos VX. Or you can take your incoming POTS or PRI or BRI or T1 circuits, and using a gateway from, say, Cisco or Patton, you can turn these lines into SIP and then use it with your VX phone system. The VX also is completely compatible with Axia's LiveWire. So if you already have an Axia LiveWire system, then you already have the infrastructure wiring to make it work. You plug it in the switch, and then it's automatically distributed to the studios where you need it. So check them all out on the Telos website. It's telos-systems.com. The point I'm trying to make here, there's a variety of phone systems and hybrids and things to help you put callers on the air. I should point out, in the roadmap for the VX product, this is really cool. There's going to be more audio codecs available in the VX. There will come a day very soon when you'll be able to pick up your iPhone, your Android phone, and instead of making a normal phone call, make a SIP phone call and make it to your Telos VX and some other new Telos products coming out, and have a wideband audio connection from the field into your Telos phone system back at the house, back at the studio. Thanks again to Telos for sponsoring the show. Telos-systems.com is the website. I encourage you to check it out, and I also encourage you to fill out the paperwork, fill out the little form for the Now catalog, and we'll send you that free of charge. Okay, back on modulation, gentlemen. We were going to touch on the subject of back before 1983, the FCC rule specified how a modulation monitor was to work, and how you were to employ it, and what it was to read. And then it seems like in 83 or thereabouts, those rules were removed from the FCC's set of rules for broadcasters. You still had to maintain your modulation within legal limits, but it was a bit more up to you to determine just how to do that. Tom, do you recall this day in FCC history when they quit telling you exactly how to do it?
Yeah, they kind of, all of a sudden, that part of the rule book was kind of empty, and matter of fact, they don't even require you to have a modulation monitor anymore, which is kind of a mind blower.
Oh, that's right.
I prefer to have, yeah, well, I prefer to have one in the station, because really, how do you know what you're doing unless you can measure it? It's weird. There was also a time, there was something in the rules, and I forget exactly how it was worded, but it talked about 100% modulation on FM, and it was something to do with X amount of cycles of 10 kilohertz tone, and you know, if X amount of cycles of 10 kilohertz tone passed through the peak detector, it had to light up the light. Then a bunch of modulation monitor manufacturers came out with an adjustment so you could actually set it so the peak detector would not respond to anything except X amount of cycles of 10 kilohertz.
Right.
Which kind of, like, I thought was kind of silly because you aren't transmitting a tone, but whatever. I don't know if anybody got caught on that.
So over a 1 minute period, that lets you actually overmodulate on several peaks before it actually counted against you. Yeah.
Correct. Yeah. And you know, it was funny because you could actually if you set the thing to max and set your modulation monitor so, you know, the peak light was coming on, as soon as you backed it down, that peak light would just stay on. And so it actually it affected the total modulation of the station.
Well, of course, I'm sorry. Go ahead. Finish up.
No, I was going to say I remember looking at the demodulated output on a scope one day, and there was a definite difference in the amount of signal coming out of the audio output of that monitor.
So the idea behind a modulation monitor that followed the pre-83 rules to their logical conclusion was that you could modulate more with a mod monitor that was a bit more lenient, that you know, let you push the limit of the rules, go to the fence. Not when, you know, some modulation monitors, when you just got near the fence, they'd say, "Oh, you're near the fence." But other ones, and I think probably one of the, I guess, perhaps by claim, one of the first ones to do that, or at least that made a big deal out of it, was from Modulation Sciences, the ModMinder modulation monitor. And it claimed, and there's a website about it. If you look for Modulation Sciences ModMinder, there's some article in here answering the question: hey, is it legal does this count my modulation legally? And according to some things they quoted from the FCC and their own logic, yes, it is legal. But it wouldn't just say, hey, you're overmodulating at the first sign of overmodulation. It would let this that has a 1 minute rolling window and counts the number of overmods in that time. Now, you know what? Of course, when we talk about this, we're not talking about the difference between 90% modulation and 110% modulation. We're talking about pretty small differences in the overall average of modulation as a function of time when you have little peaks going on. And this is also highly dependent upon what your audio processor is doing in terms of what your audio processor is doing in terms of. I'm getting audio back here delayed to my head. Hey, so it's dependent upon what your audio processor is doing in terms of its peak limiting. If it's letting a few peaks through, well, that's going to affect what the mod monitor is reading. It's going to read those things. All right, so
Kirk, I asked an FCC inspector one day about those settings on the mod monitors, and he showed me how they measured modulation, and it was what Chris described before. They set up a small FM transmitter or FM exciter. They Bessel nulled the thing to find plus or minus 75 kilohertz deviation. He used an oscilloscope to set the output of the detector, to watch that signal. Marked it on the scope, and he sat there and he said, you know what? I don't care what you have your monitor set to. As you go over that line, he says, I'm writing you a speeding ticket. Discussion ended.
Okay.
So he wasn't impressed by that little section of the rule, and he wasn't impressed with the way the mod monitor manufacturers are doing it. He set his scope up a certain way, and if you went over the line, you were illegal.
So this kind of presents a problem, doesn't it? Because the station is depending upon doing it one way that's easy to do. You don't have to do a Bessel null and a calibration and modify a tuner and all the things that Chris Tobin said he did earlier. You buy a piece of gear, you install it, you set it up according to the manufacturer's directions, and if it says you're not overmodulating, you should be not overmodulating. Folks at Modulation Sciences say they had word from the FCC that what they're doing would be counted legal. So it sounds like the field inspector had this notion that, well, you can do whatever you want to, but if I show you're overmodulating, then you're overmodulating. Is that kind of what you're saying?
Yes.
Yeah.
That's exactly what I'm saying.
I would hope that by setting up, if you're legal according to the mod monitor you've spent a lot of money for, which the designer of that says no, this absolutely works according to the FCC rules. I would hope that the variability, and I would think the variability would be in the viewing of an ephemeral little trace of green on an oscilloscope compared to a mark. I would hope that, I don't know, how can that be? How can your eye be as accurate? And actually, I think it's going to be accurate in a forgiving direction. I think if you're obviously going over the calibrated line on the oscilloscope, well, then your mod monitor ought to also be showing that you're overmodulating, unless the inspector did the Bessel null incorrectly. Chris, you got an opinion about that?
Uh-oh.
Uh-oh. No audio from Chris. Now on the in the chat room,
there we go. Sorry about that.
Oh, there he is. Go ahead, Chris, on what I said about the field inspector's calibration and interpretation.
Well, yeah, I had that same question years ago, prior to the change of the FCC ruling back in the early 80s. I asked the FCC inspector once, I said, how do you really determine where things lay, if you will, with this Bessel null and the scope and what you're doing in the car? And he looked at me and said, why? I said, well, I took a class back when oscilloscopes had tubes in them, other than the CRT, and a Tektronix engineer was nice enough to tell us that you're measuring on the scope waveforms. However, you have to take into account the phosphor delay, the decay, and the illumination. Otherwise, your measurements could be off by a small amount. So the FCC inspector agreed. He goes, you're absolutely right. The display does have a certain decay time, and the luminance might be greater or less if I'm not careful. So based on what we know, I chalk the line, grease line, if you will, or whatever. I err on the side of, okay, if you're speeding, I'm giving you the benefit of the doubt. My scope has already got a delay in it that I should be allowing you to speed just a little bit. But if I can still see it, then you must be way off. And that's what it intrigued me when in 83 and 84 and 5, when the FCC said, we're going to leave it up to the broadcasters to come up with a better method of measuring. It reminded me of that moment with the FCC inspector. I said, wow. So if I use a scope with a very fast phosphor, I'll really see those peaks that are mentioned in the ModMinder manual for modulation sciences. But if I use an older scope where it's slower, I can get myself in trouble.
Yeah,
Think about it. Anybody uses a scope, you'll know.
In the chat room, Bill Sachs, who we've had on the show before, is reminding us of what a couple of other engineers also tell me, and that is you should use a spectrum analyzer to analyze FM occupied bandwidth, and because that's what really counts. And I've got. Look, I absolutely trust what Bill Sachs says. The guy's a genius. We've had him and his wife Kim on the show before. But from a practical point of view, I guess I haven't yet understood, because I've got a spectrum analyzer, got one in the next room. I've used to use it regularly in my contract engineering business. I'm not understanding how one would use a spectrum analyzer to find peaks of modulation that you could actually do something with. So this is maybe something that we'll have to have Bill back on the show for. I've got other engineers have also told me this, and I'm happy. Maybe Chris, maybe you, or maybe Tom could explain to me how a spectrum analyzer can be used to detect and peaks of modulation to make sure you're not going over, because a spectrum analyzer is a swept device. It doesn't measure all across your signal at the same time. It only measures a little bit of spectrum at a time as it sweeps across the area of interest. Either of you guys want to comment on spectrum analyzer in a practical use?
Well, you have to come up with a time frame. Let's say 10 minutes, maybe 15 minutes, and you set the spectrum analyzer up for peak hold, and it will hold the farthest deviation that occurs over that 10 or 15 minute window. That's the only way you can do it. You can't really do it in an instantaneous mode. You have to do it over a period of time, because let's face it, your modulation and your program material is constantly changing.
Bill Sachs answered my question. Actually, he tells I'm so far behind the times. Bill says that new spectrum analyzers are not swept. They're like a real-time analyzer in DSP now. And that's something new to me. So that now it makes sense. If you had a spectrum analyzer that was a real-time analyzer, and then you put it, you have the mask. Maybe they're predefined. Maybe you draw it yourself. But you have the mask of occupied bandwidth. Then yeah, I think that this could work. So we've got to have Bill back on the show and show us exactly how that works, as he is a real expert at that. Chris Tobin, didn't mean to cut you off if you had a comment about that subject.
No, I was going to say that it's the peak over time, the hold, what Tom's talking about is exactly how it was described to me. And I wish I could remember the name of the calibrated equipment, the receiver. It was a complete unit in the back of the FCC car, and it did all that. And it did it over time. And that's what the inspector was trying to explain, that you just don't take a snapshot, because you can't. At least back in 1985, you didn't have that luxury that easily. At least none of the broadcasters I worked with had the access to those particular pieces of equipment. And you did it over time, just as Tom pointed out. And I think that's where people started playing with rule or the interpretation, because then occupied bandwidth became the buzz phrase for a while. Well, my occupied bandwidth is within the mask that the FCC claims is this, that, and the other. So I'm not overmodulating, but yet there were still stations who were cited. So it was a very difficult, I think, a way to go about it. And the FCC's intent was just simply find a new way to make measurements based on what we say is 75 kilohertz. Guard bands, if you're doing subcarriers, modulation based on that, and take it from there. And I think people just, as you put out, they went to the fence as far as they could go and push it, and sometimes toppled over a little bit. But yeah, I think it's always going to be subjective. You're never going to be exact as you'd like. And
yeah, go ahead. Sorry,
I was going to say, remind me later about the FCC inspector story about overmodulation in the marketplace and what his approach was to rein in the broadcasts if they got out of hand or if they didn't.
Actually, that's a real good thing to talk about. Let's see. I was going to cover that. I've got one. I got a Randy Michaels story that we need to cover before the show's over. So here, if I tell you what, we'll make our way to your FCC inspector's suggestion or idea. So you got a market where every station in town is doing a minimum of 120, 125% modulation. Some stations even doing 135% modulation. So nobody can afford to go to 100 because they're going to be a couple of dB softer than all the other stations in town. And what program director wants that? So when you get a market that's already done that, that everybody is speeding. Everybody is speeding. What do you do? What do you do? Tell me about the FCC inspector's idea about how to correct that.
Okay, this is the approach he would take. First of all, he told me, he goes, look, I understand the market dynamics. I get why you have to modulate above what the book says. I get it. Because I'm not going to sit here and split hairs. He goes, what I'm going to do, and he told us that at an SPE meeting once. This was nothing like backdoor, back office. This was literally right out in the open. He looked at everybody in the room and said, here's how it's going to work. I know what the market dynamics are about. I understand where everybody's modulation is. I know where it's at. I've monitored it. I can do a chart. I know exactly what you're all doing. And trust me, no one in this room can throw a rock at the glass ceiling, okay? I get it. Here's what I'm going to do. If any one of you call my office and want to complain about somebody else in town and there's an issue or whatever, I will then pull out the book and everybody will receive a visit. That's how I'm going to treat the market. And I'll never forget, this was like 1989 or 88, an SBE meeting in New York City back at the New York Times building where we used to do it in the theater. We had meetings in the theater and everyone in the room just sat like, oh. It's like you said earlier, being on the highway, knowing that if you're doing 79 miles an hour, you can get away with it, or 75, whatever the speed limits might be, and you go above. State trooper sits on the side of the road, averages all those cars, and says, all right, everybody's doing about 78, 79, fine. Leave them be. They're all moving in synchronous, motion, if you will. Then there's that one guy that comes by at 85. Okay, you're over. And then he starts picking other people.
Yeah.
That's what he did. And I'll never forget, because as you know, in the market that I'm in, modulation was never an issue, and loudness was never a concern for anybody. It just... And Tom knows, I think, the inspector I'm talking about. And,
oh, yes.
yeah, he was very fair. I mean, he was fair, and if you tried to BS him and he knew it, you know what? You might as well just pack up and go, because he'll find some violation somewhere to just burn you, just to give you grief. Because now if he's got to do paperwork, so will you. And he told me he would tell people that. I kid you not, because he hated paperwork. Because I don't want to do paperwork. It's a waste of my time. He goes, this is not the way to do it.
I got to believe this is a common problem. There are plenty of markets across the U.S. Where everybody is speeding. Tom, you run into this in your travels?
I run into it. It's a common issue. Some of us in town take the high road and decide to keep it legal. So, in hopes that some others will come down to our level, but sometimes yes, sometimes no. And it depends on the market, and depends on what's going on. Depends on who's. I've known some markets where everybody's speeding. They hear the FCC's in town. Everybody comes down to the limit. As soon as they hear the FCC's gone, everything comes back up.
Sure.
Yeah, that's true.
Yeah. The radar detectors out there. So I've lived in Nashville for about 11 years now, and I heard that. This may have been just after I moved here, that everybody in Nashville was doing 120, 125, 130, 135% modulation. And at an SPE meeting, the engineers all got together and said, look, if any one of us cranks our modulation down to the legal limit, we're going to hear about it from our program director within an hour or a day. But if we all turn our modulation down at the same time, our PDs won't know the difference. And can we agree to do that? And my understanding is, I wasn't part of the group at that time, but my understanding is that they did exactly that. They picked a Sunday night about midnight when maintenance is often done, and all the Nashville stations who were speeding turned it down to in the range of 100, 105, 110%, depending on subcarriers and such. But they were all within 1% or 2% of being legal. And I'm told that the program directors didn't notice that the loudness was the same as it was before everybody turned down by the same amount. What the people who were still at 125, 130% modulation were the rim shot stations, the ones whose engineer may not have been attending the SBE meeting. So that, you get the station 70 miles away or 50 miles away, and they're still doing 130% modulation because they're trying to hit their community with a signal just as loud as those Nashville stations. So has it stuck? I don't know. I don't know what the Nashville stations are doing nowadays. They're mostly legal. I hear. So I want to bring about one more technical item. And this is what I forgot to bring up earlier, and Bill Sachs was kind enough to remind me about it, and that is receiver-induced distortion. So let's cover this for a second. You buy an expensive piece of broadcast gear called an FM exciter, and some of them can be pretty pricey, especially those that are totally digital inside. And they have great capability of they have some headroom involved in them. They're designed to overmodulate. Now, older designs, I'm sure they were designed to operate just optimally at 100%, 110% modulation. But think about the other end. Think about the consumer end, where you've got a receiver anywhere from a $12 Radio Shack flavor radio to a multi-$100, $1,000 receiver, or more likely you've got a car radio. Well, the designers of these receivers, they want to have the receivers have the best possible specs, the lowest distortion and the lowest noise that they can design in the receiver. Well, to do that, they got to pick a point that they're going to call 100% modulation, so that the receiver's IF skirts are shaped right, so there's proper selectivity between stations, so there's good sensitivity, and so there's the expectation of an IF, that's an intermediate frequency signal, inside the radio. This is one that's getting amplified quite a bit and limited. There's an expectation of just what that IF signal is going to look like in terms of its occupied bandwidth. And if the station overmodulates, well, then the occupied bandwidth of this IF signal becomes wider than the receiver designer intended, and that's going to mean distortion. You're going to get receiver-induced, typically IF section-induced distortion. So overmodulating is for sure going to put distortion into the receivers. Not that you're transmitting distortion, you're not, probably not. But the receivers picking it up weren't designed for 135% modulation. So what do you say about that, guys? Chris, you got any notions about receiver-induced distortion?
Absolutely. The running joke we had here in town back in the height of the, we'll call it the modulation wars, was the running joke was you flatlined the composite, and then when you couldn't get any more out of your transmitted signal, you pushed up just enough so the limiter in the FM tuner did the last 2 or 3 dB you needed. I mean, that was the running joke, and there were some stations who literally came up with ways to push it, and you could hear it a little louder, and boy, were there artifacts. But to the average ear that didn't know, they didn't know different. It just sounded, louder. But yeah, there were people. Definitely, tuner-induced, receiver-induced noises has been an issue. But I think nowadays it's probably far less with all the, more moderate and somewhat more sophisticated processing people are doing.
I should point out that any real-world receiver has distortion due to its finite bandwidth. And I, once again, thank Bill Sachs for making me sound really smart. But that's absolutely true. A transmitted FM signal has a theoretically infinite bandwidth. Now, granted, the sidebands become extraordinarily small as you go out away from the main signal. So you can truncate the band, the sidebands at some point and have a reasonable distortion figure. But that's what the receiver's going to do, though. It's got to have a finite bandwidth. Tom, have you noticed this? If you overmodulate on FM, that you get receiver problems?
Oh yeah, it depends on the receiver. Basically, what I do with a lot of stations is you kind of have to make a determination as to the receivers that would be the typical ones that your average listener would be listening on, and if you can obtain, get your hands on those models, sit there and start listening to them and see what happens. And Chris is right. At some point, you crank it up until they start distorting, and then you back it down and find out what the limits are.
So some years ago, back when Randy Michaels, a rather famous operations and programmer in the business, who's now restarting a company, Merlin Media. Randy Michaels was with, I guess this may have been before it was actually Clear Channel, or maybe it was Clear Channel. I'm sorry, I don't know which, but he had a talk with his regional engineers, and the word I'm sure got to the local engineers as well, and that is that if you receive a citation from the FCC, if you receive an FCC citation for overmodulation, here's what's going to happen to you. So pay attention. I'll say it again. If you receive an FCC citation for overmodulation, I will buy you a steak dinner. He considered that a cost of doing business and being competitive. Now,
there are
I'm
a
not
lot,
sure
lot of groups that way.
I'm not sure I agree with that, but you know what? You gotta love the dog in the fight and the fight in the dog with Randy Michaels.
Yeah, no, that's true. No comment. Randy Michaels. But no, there were a lot of folks. I mean, I remember working in a market, doing some consulting work, and it was pretty much there was a budget line item. The engineer showed me in the operating budget there was a line item for FCC. What do they call it? FCC concerns or something. It was something goofy. The naming convention. But that was because they said the market's too competitive. We can't afford not to be the dominant, money maker in town. And if we have to take a hit, so be it. We'll just beg for forgiveness or say, it's only been happening for a short time. And I wouldn't be surprised if Randy Michaels, and there were probably others that would have said, great job, steak dinner, whatever, this is where we're going to do business.
Hey, we've been talking a lot in the show here about modulation monitors, and if you want to read about some, a few that we tend to use in the broadcast business, there is one made by Modulation Sciences. We mentioned that earlier. The ModMinder modulation monitor. I think the current version is called the FMMM-2. That's FMMM-2 from Modulation Sciences. Belar, B-E-L-A-R, is another manufacturer of mod monitors, and these are just gorgeous mod monitors. They make some very nice ones, and a fellow named Arno Meyer, who was honored by the NAB. Back 10 years ago. He was given the Radio's Engineering Achievement Award 10 years ago. If you go to the Belar, B-E-L-A-R website, belar.com, you can read about Arno and his philosophy about how he got started about building modulation monitors. There's also modulation monitors built by TFT, their website, TFTinc.com. And also there's, yes, right, De Sequera, especially for HD. De Sequera. I don't have their website up here in front of me at the moment, but also there's Innovonics. That's spelled with one N at the beginning, N-I-N, Ovonics. Makes modulation monitors for AM and FM. They are on the budget side of mod monitors. So you want to read about them. Seems like there was one other one I wanted to... Oh, yeah. Remember we've had on the show as a guest Greg Oganowski. Greg has done a lot of thought, theory, and practice into monitoring modulation. And his company, Modulation Index, their website is indexcom.com. Indexcom.com. Greg's been on the show, and he can tell you about modifications to various traditional, older mod monitors that makes them read more accurately or more according to the FCC non-rules that they're still following, and can give you some more loudness. And I must point out, there's nothing wrong with achieving more loudness by monitoring the modulation in a way that doesn't break the law. It is free modulation. So if you're under-modulating because you are poorly monitoring or inaccurately monitoring, then you are not using all the spectrum that you have available to you. So getting more modulation doesn't mean more density of the audio, doesn't mean more compression, doesn't mean more clipping or limiting. This is simply a linear, laws of science, free modulation if you modulate all that you legally can. Hope I'm right about that. Guys, did I say anything terribly wrong there?
No, I don't think so, no. That's right.
Okay. All right. So Anyway, hey, we're going to have to wrap it up here. We've been going an hour and 15 minutes or so. Been talking about modulation, how to measure it, and some cases about what people have done when the whole town is over modulating. How do you get the town off the drinking bench if everybody's drinking or over drinking? We hope you'll tell your friends about this week in Radio Tech. We've got another special show for you coming up next week. It'll be our show number 100. It'll be a War Stories episode, so it's going to be pretty exciting. We're going to try to have a guest on next week who will add to our War Stories fun and frivolity, and maybe learn a couple things too. If you would tell your friends about This Week in Radio Tech, I sure would appreciate it. The folks at our sponsor, Telos, would sure appreciate it. And, of course, Leo Laporte would appreciate it, too. The more people watching and viewing, the better it is for everybody. So, hey, thanks for watching. Thanks for viewing. Thanks to Burke for switching the show. And let's say goodbye. And thanks to Tom Ray in the Hudson Valley of New York. Thank you, Tom.
Thank you, Kirk. Have yourself a great evening.
I will. And also Chris Tobin.
And don't overmodulate.
That's right. I'll keep it. Let me look at the little light here. Yes, it's green. Okay, flashing green. And Chris Tobin from Manhattan, New York. Thank you for being with us, Chris.
Thanks, Kirk. Thanks, Tom. And thank you, Bert, for all the switching.
All right. We'll see you guys next week on This Week in Radio Tech. Bye-bye.